Let's finish up this lesson really quickly. We're just going to cover again even and odd functions. By definition, an even function is a function graphically that is symmetric about the y-axis. But let's say we couldn't look at the graph. Well, we know analytically on an even function, if we're given y equals f of x, and we plug a negative value in to that function, and then clean it up, do whatever the operation is for that function, and the result is that we get our original function back. In other words, let's say we have f of x equals x squared, and we put a negative into that function. We're going to get the quantity negative x squared, and that gets us right back to the quantity f of x squared. So this is an even function. We know analytically that we'll have an odd function where if we put a negative value in and clean it up algebraically and we can factor that whole negative out front, then we have an odd function. And graphically, we know that it is symmetric about the point of origin. So let's say we have f of x equals x cubed, and we put a negative into that function, we're going to get negative x cubed, which algebraically cleans up to the opposite of the function that we started with. So we get to factor that entire negative out front. And by definition, that means that this function is an odd function, and its graph will be symmetric about the point of origin. So let's look at these functions and let's see if they're even or odd. Well, this is x to the fifth plus x, and so we are going to, this 5 actually ought to be outside that parentheses right there. So if we put a negative into this function machine, we have negative x all raised to the fifth power plus a negative x. So that gives us negative x to the fifth minus x, and we can factor that negative out front, and this leaves us with that original function that we had. So we have the opposite of f of x, which means that this is an odd function. Let's do this here. 1 minus x to the fourth. If we feed that a negative x value, then that's going to clean up to 1 minus x to the fourth, or our original function g of x we started with. So that means it's even. Now, not every function is either even or odd. Some of them are neither, and here is an example of that. If we have h of x, which is 2x minus x squared, and we feed that a negative x value, everywhere there's an x we put a negative x, and clean it up, we are not going to algebraically be able to get the original function back, or even to get the opposite of the original function back. This is not h of x because it has a minus here and not a plus. So this is neither even nor odd. So analytically, that's how we would determine if we had even or odd functions. We're used to doing it graphically, but we can also do it analytically. So that finishes up this video lecture, and come to class next time and we'll work on homework.